Uh, Good morning, ladies and gentlemen. It's January 25. It's afternoon here in Los Angeles. Okay. My topic for today on my channel is I am now on lesson number 15. Lesson number 15. Lesson number 15, this now involves problems. We are on the powers of evaluating integrals of trigonometric functions. Last weekend, I am done already with the powers involving sine and cosine. That's involving sine and cosine. So for this afternoon, I will try to give example problems involving powers of sine only and cosine only. We are now through with sine and cosine. I give you two problems of those ones the last time around. So for this afternoon, I will give problems involving sine only and cosine only. Okay, let's proceed because I will be giving 4 examples. 2 problems for sine only and 2 problems for cosine only. It's not so complicated one. I just want to show how we solve problems under sine and cosine using trigonometric identities. Okay, let's proceed with example number 1. The integral of sine cube of 4x dx. It's a pure sine, so it involves sine only. And unluckily, the power of the sine is actually to the third power. Okay? So we must have to bring out the identities needed for this to solve this problem. I think we could rewrite the given problem as sine cube is sine square and sine of 4x. Sine to the second power, sine to the first power, 2 plus 1 is actually 3. So actually, we could rewrite sine cube of 4x as simply sine square of 4x, sine of 4x dx. Usually, when the power is 1, we don't write it. It is understood that the power is 1 because 1 plus 2 is actually 3. I will check my camera. Okay. Let's proceed with the solution. We will replace sine square of 4x by 1 minus cosine square of 4x. Okay. This came from the identity sine square of theta plus cosine square of theta equal to 1. So sine square of theta equal to 1 minus cosine square of theta. But this theta here for the meantime is not just simply theta, it is 4x. So instead of sine square of theta, what we will write, it should be sine square of 4x. Because the given problem, the angle is 4x. It's not only theta. So actually, sine square of 4x can now be written or could be replaced by 1 minus cosine square of 4x times sine of 4x dx. Expand. 1 times sine of 4x dx is sine of 4x dx, the integral. Minus cosine square times sine of 4x is actually the integral of cosine of 4x. And this can be written now as simply cosine of 4x to the second power, okay, sine of 4x dx. This is now integrable, and so with this. Right? There's a formula for taking the integral of sine. The value of u inside is cosine of 4x, so obviously it's not under the cosine for the meantime, it's under the power formula. Okay, let's verify the value of u for both two components. For this sine function, the value of u is 4x, du will be 4dx. It is not exact. There is no 4 inside, but the verification involves 4dx. I place here not exact. Okay. For the second one, if this falls under the power formula, the value of u will be cosine of 4x. And du will be equal to negative sine of 4x. The derivative of a cosine is negative sine. Negative sine of 4x times 4dx. Or du is negative 4 sine of 4x dx. We are missing the value of negative 4 here. Okay, so du for the second one is also not exact, but there's no problem. We could insert the missing term or the missing constant for us to integrate it. So proceeding with the integration, this will now be equal to 1/4. The reciprocal of 4 is 1/4. The integral of sine of 4x 4dx. And this is now exact. And this now falls under the integral of sine of u du. Okay? This is sine of u, and this is the complete du after placing 1/4 outside. Okay? For the second one, this should be negative open quantity. The reciprocal of negative 4 is negative 1/4. So we insert negative 1/4 outside. The integral of cosine square of 4x times the complete differential as per verification minus 4 sine of 4x dx. So after placing this negative 4 inside, this now falls under the power formula, the integral of u to the n du. Okay? Proceeding with the integration, this is 1/4. The integral of sine of 4x dx is actually negative cosine of 4x. Should be negative, right? Plus minus 1 times minus 1/4 will be plus 1/4. And this now falls under the power formula. 2 plus 1 is 3, so this will be cosine cube of 4x all over 3 plus c. Final answer, minus 1/4. This should be negative. This is a negative cosine. Negative 1/4 cosine of 4x plus 4 times 3 is 12. So 1/12 cosine cube of 4x plus c. That's the final answer. Okay. Let's proceed with example number. It's easy if you know your identities. Example number 2 that involves sine only. Okay. The given problem is the integral of sine square of theta differential theta. Unluckily, the power of sine is even. So actually, we could use the identity double angle to replace this one. Because for the meantime, we could not integrate this one. There is no formula on how to take the integral of a sine square function. So we must have to replace this by its equivalent in h double angle. And this should now be equal to the integral. The last time around, I give you this identity. That the equivalent of sine square of theta as a function of double angle is 1/2 1 minus cosine of 2 theta differential theta. Expanding this, 1/2 times 1 times differential theta is 1/2 the integral of differential theta. 1/2 times minus cosine of 2 theta differential theta, we bring out negative 1/2. The integral of cosine of 2 theta differential theta. These are now both integrable. Right? For the second one, it involves the integral of a cosine function. So, but we must have to verify the value of du for this cosine. The value of u, the value of the angle inside is 2 theta. Differential u is twice differential theta. It is not exact. We are missing the number 2 here. There is no 2. So we will place 1/2 outside, then place 2 inside. The integral of the differential of theta is just theta. Okay, that's the integral of the first one. Right? Minus 1/2 For this to be under cosine of u du, we will place 2 here, but we must have to place outside the reciprocal of 2. So, minus 1/2 times 1/2, the reciprocal of 2. The integral of cosine of 2 theta twice differential theta. And this now falls under the integral of cosine of u du. Right? So, final answer, this should now be equal to 1/2 theta. 1/2 times 1/2 is 1/4, negative. The integral of cosine is sine of 2 theta plus c. Because if you try to differentiate sine of 2 theta, it is cosine of 2 theta. So the integral of a cosine function is just the sine function plus c. That's the final answer for number 2. It's easy if you know your identities. Right? Okay, let's proceed with example number 3. And this now involves problem involving cosine only, cosine. We are now through with sine and cosine. We are now through with sine, so we'll go with the cosine only. Example number 3. The integral of cosine cube of 4x dx. Unluckily, the problem, the power of the cosine function is an odd number, it is 3. And for the meantime, we could not integrate this one. There is no formula on how to take the integral if the power is 3, right, for cosine. So we must have to use identities. Okay? This will be equal to the integral. Cosine cube can be written as cosine square and cosine of 4x dx. 2 plus 1 is 3. So cosine cube can be written as cosine of square of 4x times cosine of 4x. Then we will replace this by formula number 1. Sine square of theta plus cosine square of theta is equal to 1. Therefore, cosine square of theta will be 1 minus sine square of 4x. Cosine of 4x dx. For the meantime, the value of theta is 4x. Because from the listing I give you, it is simply theta. But what is given for the meantime, the value of the angle is 4x. So this should be equal to the integral of 1 minus sine square. Instead of only theta, it should be 4x. That's the given problem. Times cosine of 4x dx. Expand. 1 times cosine of 4x dx is cosine of 4x dx, the integral. Minus the integral. I can write sine square now will be sine of 4x to the second power times cosine of 4x dx. And these are now both integrable. Right? There is a formula for taking the integral of a cosine function, and this falls under the power formula. For the cosine function, the value of u is 4x, the value of du is 4dx. It is not exact. We are missing the 4 here. So it's not exact. Later on, we will place 1/4. For the second one, this falls under the power formula. The value of u is sine of 4x, du is cosine of 4x times 4dx. du is equal to 4 cosine of 4x dx. It is not also exact. Why? We are missing the value of 4. There's no 4 here. There should be a 4. Right? But we can remedy that one by placing the reciprocal of 4 outside. So for the first one, there should be 4, right? So the reciprocal of 4 is 1/4. The integral cosine of 4x 4dx. And this is now exact. This now falls under the integral of cosine of u du after placing 1/4. For the second one, we place 1/4 also outside because we are missing 4. So negative 1/4, the integral of sine of 4x quantity square times the complete differential. It should be 4 cosine of 4x dx. We place the 4 inside, so we place 1/4 outside. Final answer. This should be 1/4. The integral of cosine is sine. Okay, 4x. Minus 1/4. Second one, this falls under the power formula. 2 plus 1 is 3 all over 3 plus 3. Final answer, 1/4 sine of 4x. 4 times 3 is 12. So this is minus 1/12, the coefficient of the second part. Minus 1/12 sine cube of 4x plus c. That's the final answer. It's easy if you know your identities, right? Okay, let's proceed with the last example for this afternoon before we run out of memory. Okay, the last example will be the integral cosine square of 1/3 theta differential theta. The value of the angle is 1/3 theta. It's not only theta, right? So if we try to recall the equivalent of a cosine function as a double angle, the last time around this was theta. So for us not to be misled, okay, I will place alpha. Cosine square of alpha from the last time around, but that was theta the last time around. Equal to, because the given problem is theta, you might think that this theta here is same as this. It's not. Okay, cosine square of alpha equal to 1/2 quantity 1 plus cosine of twice alpha. And for this problem, alpha is 1/3 theta. So to take the equivalent of this as a function of a double angle, we follow this. Cosine square of, what is alpha? Alpha is 1/3 theta. Is 1/3 theta equal to 1/2, open bracket, 1 plus cosine of, this is 2 alpha, right? 2, but what is alpha? Alpha is 1/3 theta for the given problem. This is 2 times 1/3 theta of close bracket. Simplifying this one, 1/2 times 1 is 1/2. 1/2 times this is actually 1/2 cosine of 2 times 1/3 is 2/3 theta. So actually the equivalent of the given original problem in terms of a double angle is 1/2 plus 1/2 cosine of 2/3 theta. Then we can substitute this one now to the original integral. This should be equal to the integral of 1/2 plus 1/2 cosine of 2/3 theta differential theta. Expanding, 1/2 times differential theta is 1/2 the integral of differential theta. Okay, the second one is there's a coefficient 1/2, it's outside. 1/2 the integral of cosine of 2/3 theta differential theta. These are now both integrable. Okay, for the second one, it falls under the cosine function, but we must have to verify the value of u. U for the second one is 2/3 theta, du is 2/3 differential theta. It is not exact, NE. We are missing 2/3 from here. There should be 2/3 here. So we will introduce 2/3 inside, then counter offset that one by placing the reciprocal of 2/3, which is 3/2. So the final answer, 1/2 the integral of the differential theta is just theta, plus 1/2, okay, we will take the reciprocal of 2/3, that will be 3/2. The integral of cosine of 2/3 theta, and the complete differential as per verification, it should be 2/3 differential theta. And this now falls under the integral of cosine of u du. Cosine. So, final answer, I missed the theta here on the final answer. 1/2 theta, this should be theta. Okay? 1/2 times 3/2 is 3/4. 1 times 3 is 3, 2 times 2 is 4. And the integral of a cosine is just sine of 2/3 theta plus c. That's the final answer. If you try to differentiate this one, what will come out is this. So the integral of a cosine is just the sine of that angle plus c. That's the final answer. Okay. I think that's just more than good enough for this afternoon for the integration that involves sine only and cosine only. So the next time around, we will solve problems that involve powers of secant and cosecant, tangent and cotangent. Okay? That's all for this afternoon, ladies and gentlemen. So if you like my discussion for this afternoon, please click like. If you want to share it, please click share. And if you want to subscribe to my channel, please click subscribe. This is for you guys who are taking integral calculus for the meantime. Good afternoon, Los Angeles.